Hello and welcome to another demonstration of new features coming up in the Eclipse Papyrus project in the Neon release. Today we'll look at a new prototype of diagram-to-diagram synchronization based on the active operations framework that is currently in development as an extra component of Papyrus. So, looking at, for example, a class-like diagram, we see two diagrams that are visualizing many of the same elements. And what we'd like to do is synchronize these two diagrams so that they present the same contents or laid out in the same way. So let's hit Synchronize Diagrams. And so there they look the same. So changes that I make over here are reflected over there. And new elements that I create, they appear over there. I can take an element out of here and pop it in there. That moves it out of this package into this package. Same change reflected over there. I can create a new class in here. Oops. And a view of it shows up over there. And as we saw in the Mars release of diagram synchronization implemented on a different framework at that point, I can choose to customize certain aspects of the presentation of objects over here. Those are then no longer maintained in lockstep with what's happening in the other diagram, because, for example, perhaps I add new content to this diagram that we don't want to see over here, so I need to, make this layout accommodate that. I can also create, obviously new edges in a diagram, like so. And certain aspects of the layout of these things is maintained, other things are not. So for example, anchor points are dependent, or a fairly specific aspect of the layout. This prototype hasn't got to the point yet of synchronizing style information like fonts and so on. So that's a look at synchronizing class diagrams. Now, also inspired by the use cases of UMLRT, we have synchronization of state machine diagrams. So the interesting thing about this state machine synchronization use case is that the diagrams we're dealing with are not two different visualizations of the same model element, being a package that has classes in it, but there are two different visualizations of two different model elements. So let's go here and say we're going to synchronize these. I call them capsules. That's the UMLRT lingo. So immediately we see that a state machine has been created to represent the behavior of this capsule class, which is a sub specialization of this one. So why don't I go ahead and create a diagram for that also. Create a new state machine diagram. I'll call it whatever. Put that over here so that we can see them side by each. And what we'll do also then is we'll synchronize these diagrams. So now, whenever I add new content to the state machine in the superclass, like so, we see the same elements created and visualized in the state machine of the subclass. So we can keep going like this. All right, the layout information, of course, is maintained in sync as usual. I can redirect edges, and the corresponding transitions are redirected in the other one. Undo and redo is fully supported because unlike the Mars implementation of this synchronization framework, this new implementation doesn't implement the synchronizing changes as pre-commit actions on EMF transactions. They're triggered immediately from adapters attached to the notation views. And in fact, the implementation of the diagram synchronization is implemented in terms of the EMF-based notation model and not the GEF edit part model. So in fact, that simplifies a good many details of the implementation of that synchronization, but also makes it more readily portable onto a GEF4 based diagrams when the time comes. So of course, as before, we can, in the specializing state machine, the redefining state machine, we can add elements that are not present in the parent state machine, like new states and transitions. And we can also redirect transitions so that they now are no longer synchronized with the corresponding transitions in the parent state machine. So there you have it, the synchronization of diagrams, a new prototype in the Neon release. Thank you.